So it's recording. Mariah, do you have any questions?
Yes, I have a few problems I wanted to go over.
Okay. Let me get my tablet out just a second.
Okay.
I'm glad that you texted me because, like I said, I completely forgot. All right, so you should be able to share your screen, Mariah, if it's something you want to show me the problem.
Okay.
I don't know what that was. You go to the far right bottom, and there should be like a little purple arrows. You take that out, and then there's a little box with the arrow going off to the right. That's the share button.
Okay.
And then somewhere on that menu is share.
It looks like it's not allowing me to share my screen.
Okay. I wonder if I can change that. I don't see it. Okay. Let me see. Participants, post chats. Yeah, it just says share audio, video, post chat messages, draw a whiteboard. Okay. All right. So what's the So what was the question?
Right, did you set up a whiteboard? I was having some malfunctions with my laptop, so that's why I came in late.
No, I didn't. I didn't set. I was just gonna use my PowerPoint files and write on those.
Okay, yeah, I'm finna get
This actually also has a whiteboard, but I don't know if I can use my tablet with it.
Okay, yes, I'm finna get what I needed help with.
So, Mariah, what was your question? Or what was the first one?
Can I send you the question through the number you told us to text you on?
Sure.
Okay.
Okay. All right. So major component. Okay. So this is from Alex, and let's see. Let's see if I can do whiteboard. I don't know if I can or not. We'll see. Okay. Put things where I can see them. Okay, so it talks about, yeah, see? No, of course I can't do whiteboard. All right. I think I tried that before and it didn't work. Okay, so go back to share application screen, entire screen, allow. Okay, there we go. Okay, so this problem was talking about, I'll find a place for everything in a minute. I guess it just erased it. Okay. Change my. What's it not liking here? Oh, I don't know what that just did. Okay. All right. So I have C8H16, which is the octane. It says it's combusted with oxygen in the air to produce carbon dioxide plus water. And yeah. It says that I have 9.04 grams of octane. What is the mass of oxygen? 9.04. So I have 9.04 grams of this, and it wants to know what's the mass of oxygen. All right, so the first thing is that you had to write out the reaction, like I just said. The second is that you now have to balance it. So I need to put an 8 in front of the carbon dioxide, so 8 and 8. I need to put 16, I need to put an 8 in front of the waters over here. And then I got 16, 8 is 24, so I need to put a 12 in front of the oxygens. So that should be balanced there. Okay. The other thing I need is the molar masses. And so for the octane, it's 8 times 12.01 plus.
Right, I got a question.
Yeah.
Okay, cause I get confused on that part sometimes. Why did you put the 12 in front of the O2?
Because the fact, let me change colors down here. So
okay, yes, ma'am.
Okay. So, and I lose it. Where's the cursor? Way over there. Okay. All right. So this 8 times 2 gives me the 16, okay. And 8 times 1 is 8. And so when I add those up, I get 24.
Oh.
Right?
Yes, ma'am.
And so what do I put in front of, what do I multiply by 2 to get 24 on this side? And it was 12.
Oh, okay, I see.
Okay. All right, so back to the molar masses. These days it's going to be a bad thing. I do 8 times 12.01 for the carbon and 16 times, whoops, I didn't do that right. 16 times 1.01, yep, for the hydrogens, and I got 112.24. So the molar mass of this is 112.24, and that's in grams per mole. And the molar mass of an oxygen is 2 times 16, so it's 32.0 grams per mole. Okay. So I start with the number that was given, which was 9.04, and that's grams of C8H16. And to be able to compare amounts in the chemical reaction, what unit do I have to be in? Anybody? Can I go straight to grams of oxygen?
No.
Okay. So what unit do I compare these two amounts in? I can read this sentence as being 1 molecule of octane plus 12 molecules of oxygen goes to form 8 molecules of carbon dioxide and 8 molecules of water. What else can I use instead of molecules? What other unit can I use?
Moles.
Moles.
Moles. So how do I go from grams of octane to moles of octane?
You gotta divide.
Divide by what?
Times the not the 112 point
The molar mass, yeah, the
mhm.
112. Because divide is only half the answer. I have to say divide by what? So 9.04 divided by 112.24 gives me 0.08054, and that's moles of my C8H12. And then what's the relationship between my octane and my oxygens?
One over 12.
The 12 goes with the oxygen, and I want to cancel out the octane.
So 12 over 1.
12 over 1. So it's 12 moles of O2 over 1 mole of C8H16. So what I come from is always on the bottom, and what I'm going to is always on top. So I times this times 12, and I got 0.9665 moles of O2. And then it's asking for the mass, so how do I go from moles to mass?
You gotta multiply
By?
100.
Nope.
Oh wait,
That's a percentage. By the molar mass. So by 32.0 grams per mole. So times 32 gives me 30.9 grams of O2. Okay. Now, I've said this several times in class, and I'm really nothing about it. Okay. You have to, because part of chemistry is being able to work the problems in a time manner. So you have to know how to do this calculation without really even stopping to think about it. So you need to know that if I'm going from mass to moles, I divide by the molar mass. And you also need to be able to do this without thinking about it, is I need to know this one is to go from moles to mass. I multiply by the molar mass. Okay? So you almost need to have that so familiar to you that you don't even stop to think about it. Because working a problem is part of the time. Working a problem in a timely manner is part of the mastery. And so when we make timed exams, we're looking at that. And these two calculations right here in the green and the purple are things you're going to be using all this semester and all next semester. So, and the third thing I would add, of course, to this would be you need to know without thinking about how to calculate molar mass. Because if I'm using molar mass a lot, I need to know how to calculate the molar mass. So if you have to stop and think about these two steps, you're just not going to have time to work all the problems on the test. So, all right, what are the questions you got? I think that was Mariah had the first question. You said you had several. What's the other one?
I would like to work out a precipitation reaction question.
Okay. Do you have one in particular?
No, not one in particular.
Okay. Okay. Let's see. I've got two computers sitting here. Let's see. Where I get most of my problems. See, we're not teachers pay. Alright, let's try that again. Let's see here. There's a key, but that's okay. Okay, so this one had a problem of lithium carbonate, Li2CO3, aqueous, plus cobalt-2 acetate, C2H3O2, aqueous, goes to form what? So the first thing is to realize the double replacement. So I'm going from lithium to acetate. So lithium is a +1 charge. Acetate is a -1 charge, so it's just LiC2H3O2. And the cobalt goes with the carbonate, but if it's on the left-hand side of the molecule here, it's going to be on the left-hand side on the other side. So it's CO, and that was a 2+, and CO3 is a 2-. So that becomes COCO3. Okay. And then I need to balance it. I've got one lithium here. I'm sorry, two lithiums here and one here. So I need to put a 2 there.
I have a question.
Sure.
Why didn't you put acetate in parentheses?
Because there's only one of them. So I only need parentheses. Whoops. Sorry. Because I miswrote it at the beginning. There was a there was a 2 there. Sorry.
Okay, I see.
And so when there's only one of them, I don't need to put parentheses around it.
Okay.
Okay. So I'm going to skip carbon and oxygen because they're in multiple places. I've got 3 times 2 is 6 hydrogens here. I've got 3 here times 2 is 6 hydrogens there. I've got 1 cobalt and 1 cobalt. So now I've got 1 plus 4 carbon, so that's 5 carbons. I've got 2 times 2 is 4, plus 1 is 5 carbons. And I've got 3 plus 4 is 7 oxygens. I've got 2 times 2 is 4, plus 3 is 7 oxygens. So it's balanced at this point. So my reaction is LiCO3 aqueous plus CO C2H3O2 aqueous goes to form 2 LiC2H3O2s. The last thing I need to do is put in the phase COCO3. So is lithium acetate soluble or insoluble?
It's soluble.
It's soluble. I don't even care about the acetate, which all acetates are soluble. If I just look at lithium, lithium's in group 1A. So if I just look at lithium, all group 1As are soluble. So therefore, it doesn't matter what it's attached to, it's soluble. All right, cobalt carbonate, cobalt 2 carbonate. Is it soluble or insoluble?
It's insoluble.
It's insoluble, it's solid. Most carbonates are insoluble. The only exception to that would be that first, which is the group 1As, and cobalt's not a group 1A metal. Okay, so that's the end of that one. Here's one for you to try. NH4Cl aqueous plus copper, this person likes acetate, copper 2 acetate aqueous goes to form what? So I want you guys to try that one first. And this is really CU. If you want me to, I can set up a whiteboard.
Yes, please.
Okay. Let me figure out what I'm doing here. That will work. Okay, so whiteboard.fi. And say new class. Okay, so there's the code G77B3. Somebody's knocking, so hold on just a second. Hold on. The door's locked. Oh, you came to do the lab, didn't you?
Yes, ma'am. Thank you.
Oh, I gave you the wrong key. There's only 2 on there that are Midland keys. So it would have taken you forever.
It's just a market too, right?
Yes.
Okay.
So the one that you can see the numbers is the 3rd floor. The ones without that you can't really see the numbers is the 2nd floor.
Okay. Dr. Burke, can you go back to the problem you gave us?
Yes. I can actually see here. Make it. Can I write on this? We'll see. It was. Oops. I lost that screen. I get dots. Okay. It's not gonna let me do that. Okay. There you go. I should have set up the whiteboard on my other computer here, because I can't see both screens. Okay. Just curious. You working on it, Mariah?
Yes, I'm working on a whiteboard. You can't see it?
I can't see it now.
Okay.
And I was playing around with it since I have two computers here sitting by side. I'm a student in the other one. Oh, now I see it. Okay.
Okay.
How come yours is so much smaller than mine? Can I control that? How do you make yours appear so small? Your letters and stuff.
I think it's because I was using a really tiny line width. So,
Yeah, but how do you set that? Just
oh,
out of curiosity.
there's a little like slide on the side where you can change how big you want your line to be.
Oh, mine didn't have a slide. It's interesting. Yeah, mine didn't have a slide anywhere. Maybe. Oh, there it is. I found it. Oh, yeah, much better. I don't play with these things as a student very often.
I understand.
It's not updating it again, too, either.
That's weird. I don't know why I finished the equation.
Oh.
Hmm.
I mean, mine was updating. Mine as a student was updating. Okay, so I'll go ahead and do it. Let's see. Now that I see that, I also don't see a, well, there's an eraser, but it erases the whole thing. Okay.
I didn't find an eraser either to erase specific parts.
Yeah. All right, so I have, whoops. Yeah, okay. So much for that. Okay, so I have this, and it's going to form NH4 plus and a C2H3O2 minus. So that becomes NH4C2H3O2 plus my copper, which is a 2 plus charge, and my Cl, which is a minus 1 charge. So it's going to be CuCl2. So if I balance this, I've got one nitrogen. I've got one chlorine and two chlorines, so I need to put a 2 here. But when I do that, I change my nitrogen, so now I need to put a 2 there. And I'll give you a little hint. You see how this stays C2H3O2? I told you when it goes as it becomes an ion to treat it as a whole. I can treat it as a whole, balancing it too. So I can treat both the NH4 and, so I can treat this as a whole because it's the same exact thing here and here.
And you treat that as a whole, okay.
And I can treat this as a whole when I'm balancing this and this. So actually it's balanced at this point. Okay, so I have two NH4 Cls aqueous plus Cu parentheses C2H3O2 2 aqueous goes to form two NH4Cls plus CuCl2. Okay, so is the NH4Cl soluble or insoluble?
It's insoluble.
Nope, all NH4s are soluble.
Oh, wait.
So this one's aqueous. What about the copper 2 chloride?
Insoluble?
No, most chlorides, which halides, chlorides, bromides, and iodides, are soluble except for silver, mercury, lead. This is not silver, mercury, and lead.
Okay.
So this one is also soluble. So guess what? This is what they call a no reaction. Nothing actually happened. It stayed clear. So just because I mix two things doesn't mean a reaction goes forth. Do you have other questions?
Dr. Bright, I have a question. On the last homework that we had, will we have one on the chart where you had gave us like it was grams, 2 grams, and I think we had to find, let me see if I could go back to the last homework because I struggled on that. Let me see. Whiteboard.
I have a feeling you're the only one still here. No, there's other people here. They're just being completely silent.
Okay, yes, I went back to homework 5. Will we have one where it would be like we would have the chart with the product and the mass, where we could have 2 grams with the carbon dioxide in the water and the 2 grams? Because I struggled on one of them where it had 5.00 grams of a certain compound.
Which problem number is that?
It's problem 5 on problem 6 on homework 5.
Okay, so hold on just a second.
Okay.
Oops, I don't really want to go away from there. It doesn't matter which one. I've got both 9 and 10. It doesn't matter. They're the same. Assignments. Homework 5, right?
Yes, ma'am.
Preview. And then you said question 6, right?
Yes, ma'am.
Okay. So
let's see. Yes, I struggled on that one. I don't know if what I was doing wrong, but every time I would put what I had in, it would tell me it was wrong.
Okay, first of all, do you know about this explanation tool over here?
No, I just really found out about that yesterday once I finished my homework.
Okay, so because it's going to tell me, it's going to give me this dire warning that I'm going to lose an attempt. And that's okay because when I do the homeworks, you have unlimited attempts.
Okay.
So that doesn't matter. Okay, so let me take a picture of it. So this is a combustion problem. And, okay. And then I can go back to PowerPoint and go page down. Yeah, I'm not juggling so well. And so it tells me that I have 8.5 grams of a compound. That compound has carbon, hydrogen, and maybe oxygen. It may or may not have oxygen. And so it tells me that I get 12.47 grams of CO2, and I get 5.10 grams of water. Okay, so this is, and it wants to know what is the, oh, it also told me, I can't see my whole screen. The molar mass was 150, and it wants to know what's the molecular formula. Okay, so I'm going to use my carbon dioxide to get carbon. I'm going to use my water to get hydrogen. So in order to do that, I need the molar mass of CO2, which is 44.01 grams per mole. I need the molar mass of water, which is 18.02 grams per mole. I'm going to need the molar mass of carbon, which is 12.01 grams per mole. And I'm going to need the molar mass of hydrogen, which is 1.01. I may or may not need the molar mass of oxygen. I'll go ahead and write it down as 16 grams per mole. So what I'm going to do is I want to take this mass of carbon dioxide and find the mass of carbon. So I almost took that computer over. That was not good. So I'm going to find the mass of carbon. So I'm going to take 12.47 grams. And this is just like what I before, the fact that this is really, really important. So I have to go to moles to be able to compare amounts. So I have to divide by the molar mass of 44.01. So 12.5 divided by 44.01 gives me 0.2840 moles of CO2. And then I need to go to carbon, so 1 mole of carbon over 1 mole of carbon dioxide means I get the same answer, 0.2840 moles of CO2. Now for the problem in which it told you it was carbon and hydrogen only, I can stop there. But the maybe oxygen means I need to take it all the way to mass. So then I have 0.2840 moles of carbon times the 12.01, and I get 3.41 grams of carbon. And I need to do the same thing for hydrogen, so I need to find the mass of hydrogen. So I'm going to start with the 5.10 grams divided by the 18.02. And that gives me 0.2830. moles of water. But this time the ratio is the fact that there's two hydrogens for every one oxygen, or one water. So times 2 gives me 0.5660 moles of hydrogen. And so 0.5660 moles of hydrogen times the 1.01 gives me 0.5717 grams of hydrogen. Now, to see if there's oxygen there or not, if I add 3.41 plus 0.57, I get 3.98. So if this mass, it doesn't equal,
there's something wrong with it, right? Because I remember you
the
saying
8.5.
about that.
Right, so now the mass of oxygen, so that means there is oxygen there. The mass of oxygen is going to be the 8.50 minus the 3.98 to give me 0.45, or give me 4.52 grams of oxygen. So now that I have the masses, I go into finding the empirical formula. Okay, and just because I'm running out of room on this slide, I'm going to take a picture of this and go to the next slide. Okay. So I have 3.41 grams of carbon. I have 0.572 grams of hydrogen, and I have 4.52 grams of oxygen. So to find the empirical formula, I need to divide each one by its atomic mass. Don't need that anymore. So 3.41 divided by 12.01 gives me 0.2839. 0.572 divided by 1.01. And you'll notice that that's the answer I had on the previous step, where I told you could stop if there was an oxygen, or the possibility of oxygen, the 5663. So what I'm saying is, see these two numbers here? Those two numbers are very much the 0.2840 and the 0.5660, those two numbers. So if I didn't have the possibility of oxygen, I could have stopped there and then divide by the smallest.
Oh, it would have gave you an answer right there.
It would have, because of the fact that there was possibly oxygen, I had to keep going. So 4.52 divided by 16 gives me 0.2825. So I'm going to divide all three of these by the smallest of 0.2825. 2825. This, of course, is 1. And 0.2825. This is going to be, I think that's going to be 1, but let me double check. 0.39 divided by 0.282. Oops. 25. Yep, that's 1. And 0.5663 divided by 0.2825 is 2. So that means my empirical formula is CH2O. And my empirical weight is 12.01 plus 2 times 1.01 plus 16.00. So 12.01 plus 2.02 plus 16 is 30. So N is the 150 from the previous slide divided by 30 to equal 5. So that means that my molecular formula is going to be 5 times CH2O to give me C5H10O5. And that's my final answer. Questions?
No, I understand it now. So, like, on my homework, can I go back and retry them again? Or whatever I got was already put in the grade, but is that my final grade on it, or what?
You can, but realize that if you go back and do it again, there's a late penalty of 5 points per day assessed.
Okay, yes, ma'am. Thank
So
you.
you might be, it depends on what your grade was as to whether it's worth it or not.
Okay, yes, ma'am.
So. Because I think this problem, I'm going from memory. No. No. Okay. I thought there was one that was just carbon and hydrogen, but I don't see it. Maybe I shuffled the order. And see, this one's basically the same thing, but you take these percentages to grams. Okay, so this one says carbon and hydrogen only. I knew there was one there somewhere. So I could have stopped at the moles there and just done the mole ratio at that point. Any other questions? Shanice, do you have any questions?
Ma'am, you answered mine, and then we went over the precipitation part. So, and
Oh, okay.
so
Yeah, I can't tell who's
that's
talking.
what I was.
All right, so Mariah, do you have any questions? I didn't know who was talking.
No, I don't think I have any other questions. I just get confused when I'm given word problems. I don't know which steps to use with what word problems. I always get confused about that.
Well, that's why, okay, so that's why I tell students the first thing you want to do is you notice that it was number 6. I took this information and I did what? I went through and I basically took out the numbers, right? I identified what was there and I just took out the numbers. I usually also add, well, I did, I just didn't put a question mark. They want to know what the molecular formula is. Normally, I would also put it as being equal to what, that's what I'm looking for. Okay? Even if you go back to this problem, okay, I have, when it says what's the mass of oxygen, you notice that I took that and made that, I put that as my unknown. So I always take the word problem part out and just make it numbers. And this doesn't have it, but if you go back to a density problem, I will even assign a variable to it. So let me go back real quick. Let me close this one. Can I, oh, there it is. Let me close that one and there. So let me go back, and that was probably homework 2 if I had to guess. And I just want to show you just because I'm looking for, I don't know why I'm looking in particular for a density problem, but I am. Okay, so for this problem here, okay, I would write down a student needs 80 milliliters. Okay, milliliters is a unit of what?
Volume?
Volume. So I would literally write down, so if I was doing this problem, I would underneath it, I would write volume is 80 milliliters. And then I would say, and student discovers that the density 0.706. So they even tell you what that variable is. So I would write then underneath that, I would say that density was 0.706 grams per, that was a G, centimeters cubed. And then it says calculate the mass. So underneath that, I would say mass is equal to what? So by doing that, now I can look at my formula sheet and say, oh, I have a formula that has density is mass divided by volume. That might be what I need to do. Does that make sense? So if you take the numbers out of the problem and take it out of a word problem form, I think that will help you. We don't have much of that for this test because this test, we have very few formulas.
Okay, that makes sense.
So that's why I said you really want to know these two things here, because there's, I mean, yeah, the formula is not given to you on the formula sheet. These two processes, well, three. The mass to moles, which means you divide the mass by the molar mass. The moles to mass, you take the moles times the molar mass, and calculating the molar mass, of course, that you need for both of those. So you need to be able to, that's not given to you on the formula sheet, and you just need to practice enough that you get used to doing those processes.
Okay.
So practice is your number one friend. So I posted this weekend, I posted all the answer keys that we had done so far. I didn't post the one from yesterday, but I posted the other ones. I would go back and you can print out or do the worksheets that are on the D2L. You can go back and do those, and then I have the answers also posted.
Okay.
So if I go into the class and I go to content, I think this is the first one. Okay. Oops. Well, I didn't go back and do that one. The balancing reactions, I didn't do that answer key. Okay, so I thought I hit them all. I went back 2 weeks. There we go. So if I look here, the worksheet from 9-9, this is where you submitted it, and now the answers are there. So if you go back and do this one, you can do the problems, and then after you do the problems, go back and check your answers. Don't look at the answer key until after you've attempted it, because you will think you know how to do it because you looked at the answers. Okay, but I wrote all the answers out. And now that I realize that I'm missing one, I will get that one out. I will do that one. I thought I was done. I got half an hour for lab. I can get that done. So I need to go back and do the, I did the chemical nomenclature. I swear I did. Maybe that's in the week before. Let's see. Okay, I made out the answer key. I don't know where it is. Okay. The one really long answer, the one really long one, I guess I just didn't post it, but I have it worked out because I know it's on my computer because I typed it all in. Where is it? It's a PDF. Density lab. Is it this one? Well, that's the worksheet. 831 answers. Oh, there it is. I just didn't post it. I'll get that posted. So this is the first nomenclature worksheet that we did. So I have that one done. So I'll go back and check the earlier folders, make sure I got them all done. Actually, I can do that now. Watch the magic of chemistry. Okay, so I want to upload files. This is the 9 o'clock. I'll go back and do it for the 10. And click and drag over to there. Say add it. And whoops, wrong folder. Let's see. I want to move to this one. Now, there it is. Oh, there's the 831 worksheet answer. I already did already have it in there. I just don't have the balancing reaction one. Or no, it moved it up there. So there it is. It's now in the 9 o'clock. I need to go back to the 10. Any other questions though?
No, I don't have any other questions.
Anybody else? I'm going to do this while I'm thinking about it because we all know I have no memory no more. It stinks that I have no memory. I completely and totally forgot this help session today. I'm glad that somebody texted me. Oh, see, it's already there. Worksheet 831 answers. Okay. All right, well, if you guys don't have any more questions, then I will stop recording.